Quantum mechanical model of atoms, actually it is the picture which describes the structure of the atom, and this quantum mechanical model of the atom has been taken. It is the application of the Schrödinger equation to atoms. Schrödinger equation I will not describe because it is the out of scope of the present syllabus, chemistry syllabus class 11 CBSE. But we should know what is the important features of this quantum mechanical models of atoms, which was derived from the Schrödinger equation. I told that there is some 5 important features of this quantum mechanical model of atoms. So I'll describe now one by one. Number 1, the energy of electrons in atoms is quantized. Quantized, what does it mean? Because the electrons will not take randomly energy. The electrons in atoms will take only those energies which has certain specific values. For example, when electrons are bound to the nucleus in atoms, that means when the electrons are bound by the nucleus in atoms, then it will take some specific energies, and that's why it is called that energy of the electrons in atoms is quantized. Second point, the existence of these quantized electronic energy levels is a direct result of the wave-like properties of electrons. From the previous class, already we understood that electrons has dual properties. Out of these, one property, very important property, is the wave-like properties. And this is the result from the quantized electronic energy levels. And this existence of quantized electronic energy levels are allowed solutions of the Schrödinger wave equation. That means whatever we understood, that from the Schrödinger wave equation we got the model of the quantum mechanical model of atoms, and there the quantized electronic energy levels at different point it exists, and it is due to the wave properties of electrons, which is solved by the Schrödinger wave equation. I already told that we don't have scope in the present syllabus to discuss in details about the Schrödinger wave equation. In higher class, definitely you will drive and you will understand the Schrödinger wave equation. Point number 3, both the exact position and the exact velocity of an electron in an atom you can't determine simultaneously. That means at a certain time point, it is not possible to determine the exact position and exact velocity of an electron. This I already discussed in the previous class during the discussion on the topic Heisenberg uncertainty principle. The path of an electron in an atom therefore can never be determined or known accurately. It is very clear from the Heisenberg uncertainty principle. It is not possible to know accurately the path of the electrons in an atom and its position and velocity both. So That is the reason we'll talk about the probability of finding the electrons at different points of an atom. That means we will not know accurately the path of the electron. Only we'll talk about the probability of finding an electron at different point in an atom. And number 4, an atomic model is the wave function psi. Wave function always denoted by the psi as per the Schrödinger wave equation for an electron in an atom. Whenever an electron is described by wave function, then we can say that the electron occupies that orbital. And since many of the such wave functions, because there is the number of wave functions as possible for an electron, so there will also be the many atomic orbitals in an atom. Because atomic orbitals is nothing but it is the wave function psi. So there are possibilities of several wave functions for an electron. So there is the several atomic orbitals or many atomic orbitals in an atom is possible. These one electron orbital wave functions, whatever I discussed, that orbital means nothing but wave functions or orbitals in plural sense, it forms the basis of the electronic structure of atoms. That means nowadays, whatever we are observing the electronic structure of atoms, that is derived from the one electron orbital wave functions theory. And in each orbital, the electron has a definite energy. Previously, I already told that an electron in each orbital has the quantized energy. That means in each orbital, they have this energy as a definite energy. And an orbital cannot contain more than 2 electrons. Here we have to remember that an orbital always should have maximum 2 electrons, not more than that. In a multi-electron atom, that means where the more than one electron present in an atom, the electrons are filled in various orbitals in order of increasing energy. That is very important point, that in an atom there is a number of electrons. In that case, the electrons will fill the various orbitals according to the increasing energy level. For each electron of a multi-electron atom, there shall therefore be an orbital wave function characteristics of the orbital it occupies. We know that every orbital has a wave function. All the information, that means electron is occupying the certain position in an atom according to the increasing of the energy, and all this information about the electron is stored in its orbital wave function psi. And quantum mechanics make it possible to extract this information out of psi. Now point number 5. Previously, I already told that probability of an electron only we can count. So in point number 5, the probability of finding an electron at a point within an atom is proportional to the square of the orbital wave function. That means chi square at that point. So what is the chi square? The square of the orbital wave function. The chi square is known as the probability density and is always positive. That means chi, alone chi, it is the wave function, but the chi square, it is known as the probability density, and the chi square value always will be positive. So what does it predict the chi square value? From the chi square value at different point within an atom, it is possible to predict the region. We told that chi square is nothing but the probability density. So from this probability density, we can predict the region around the nucleus where the electron will most probably be found. That means chi square value is density. So where the density will be higher, then there the probability of electron is maximum around the nucleus.